Alright, in this video we're going to learn how to carry out hypothesis tests for discrete distributions. So that's going to be your binomial distribution as well as your Poisson distribution. So the steps for carrying out a test under discrete conditions are very similar to those of carrying out a test under normal conditions. So the first step is to define your random variable, then state the distribution of that random variable, then state your null and alternative hypothesis. Then again, define the distribution, assuming H0 is true, state your rejection rule, substitute test statistic into H1 and evaluate probability, use rejection rule to determine whether or not to reject H0, conclude in context. Alright, so let's look at an example. I've got one example for binomial test and one example for Poisson test. So here we're given that Arvind uses an ordinary fair six-sided die to play a game. He believes he has a system to predict the score when the die is thrown. Before each throw of the die, he writes down what he thinks the score will be. He claims that he can write the score more often than he would if he were just guessing. His friend Lakshmi tests this claim by asking him to write down the score before each of 15 throws of the die. Arvind writes the score on exactly 5 out of 10 throws. Test Arvind's claim at the 10% significance level. Alright, so let's define our random variable x. So this is going to be the number of correct scores that Arvind gets, number of correct scores for Arvind, and x follows a binomial distribution, and our sample size is 15 throws. And what we're investigating is our probability here. So H0, our null hypothesis, says that the probability should be, since this is a fair six-sided die, it should have 1 in 6 chance of getting the correct score. But if it is not guessing, then it means this probability should be greater. It should be getting a correct score more than 1 out of 6 times. Alright, so assuming H0 is true, we can define this distribution. X follows a binomial distribution, 15 with the probability of 1 over 6. Okay, and this is going to be a test at the 10% significance level. So let's create a rejection rule. Reject H0 if the probability that x is h1 greater than, you also add an or equal sign. So if your h1 was less than, it would be probability that x is less than or equal to. Alright, so this is greater than or equal to our test statistic, and if this is less than our significance level, which is 0.10. So what's our test statistic? How many correct scores does Arvind get in these 15 throws? That's going to be our test statistic. In these 15 scores, Arvind writes the correct score on exactly 5 out of 15 throws. So 5 is our test statistic. So we need to find the probability that x is greater than or equal to 5. And then we're going to compare it to our significance level. So we can write this as 1 minus the probability that x is less than 5. So this is 1 minus, that's going to be, we want x is 4, x is 3, x is 2, x is 1, and x is 0. So that's going to be 15, choose 4 multiplied by 1 over 6 to the power 4 times 5 over 6 to the power 11 plus 15, choose 3 multiplied by 1 over 6 to the 3 multiplied by 5 over 6 to the power 12 plus 15, choose 2 multiplied by 1 over 6 to the power 2 multiplied by 5 over 6 to the power 13 plus 15 times 1 over 6 times 5 over 6 to the power 14 plus 5 over 6 to the power 15. Alright, so this is 1 minus, let's evaluate each probability. We've got 15, choose 4 multiplied by 1 over 6 to the power 4 multiplied by 5 over 6 to the power, that's 11. And so this first expression that we have here gives us 0.141754 plus, let's go to 15 choose 3. So 15 choose 3 times 1 over 6 to the power 3 multiplied by 5 over 6 to the power 12, and this gives us 0.236256 plus, let's go to 15 choose 2, that's times 1 over 6 to the power 2 times 5 over 6 to the power 13, that's 0.272603 plus, let's go to 15 choose 1, so that's 15 times 1 over 6 times 5 over 6 to the power 14, and this gives us 0.194716 plus, finally 5 over 6 to the 15, and that's 0.0649055. Okay, so let's simplify this. This is 1 minus 0.141754 plus 0.236256 plus 0.272603 plus 0.194716 plus 0.0649055, and this gives us 0.0898. Okay, so this is the probability that x is greater than or equal to 5. Now let's compare it to our significance level. 0.0898 is less than 0.10. It's less than our significance level. So according to our rejection rule, we have to reject H0. So reject H0, and we can conclude that there is sufficient evidence that this guy is not guessing at all. He's got a system. So there is sufficient evidence at the 10% significance level to suggest that Avent, let's see how they worded it, to suggest that Avent has a system to predict the score when the die is thrown. To suggest that Avent has a system to predict the correct score, to predict the score when the die is thrown. When the die is thrown. So this is how we carry out a test under binomial conditions. Let's look at an example of under Poisson conditions. So in the past, the number of inquiries per minute at a customer service desk has been modeled by a random variable with a Poisson distribution and lambda as 0.31. Following a change in the position of the desk, it is expected that the mean number of inquiries per minute will increase. In order to test whether this is the case, the total number of inquiries during a randomly chosen 5-minute period is noted. You should assume that a Poisson model is still appropriate. Given that the total number of inquiries is 5, carry out the test at the 2.5% significance level. So let's start off by defining our random variable x. So this is the number of inquiries per, and they said in order to test whether this is the case, they used a randomly chosen 5-minute period. So our random variable is going to match this interval as well. So per 5 minutes. All right. So x is going to follow a Poisson distribution with mean lambda, and H naught here is going to be that lambda remained the same. Lambda did not change. And so what was lambda? Remember, we're doing this in the context of a 5-minute period. This lambda that we've been given, 0.31, is per minute. So it means lambda here should be 0.31 multiplied by 5. So lambda is equal to 0.31 multiplied by 5, that's 1.55. So it means that H naught is lambda remained the same, lambda remained as 1.55 per 5 minutes. And H1 is they're testing whether this will increase. So whether lambda will become greater than 1.55. So assuming H naught is true, we can rewrite our distribution here, x, and say that our lambda is 1.55. And now let's create a rejection rule for our test. So we can say reject H naught if the probability that x is greater than, or we always add an or equal to sign, our test statistic, if this is less than our significance level. Our significance level is 2.5%, so that's 0.025. So what's the total number of inquiries that they found in this 5-minute period? They found a total number of inquiries of 5. So that's going to be our test statistic. So let's evaluate the probability that x is greater than or equal to 5. Greater than or equal to 5. We can again write this as 1 minus the probability that x is less than 5. So this will be 1 minus e to the negative lambda, which is 1.55. And we want x is 4, x is 3, x is 2, x is 1, and x is 0. So that's 1.55 to the power 4 over 4 factorial plus 1.55 to the power 3 over 3 factorial plus 1.55 to the power 2 over 2 factorial plus 1.55 plus 1. Alright, so let's punch this into the calculator. That's 1 minus e to the negative 1.55 multiplied by 1.55 to the power 4 over 4 factorial plus 1.55 cubed over 3 factorial plus 1.55 squared over 2 factorial plus 1.55 plus 1. And this gives us that the probability that x is greater than or equal to 5 is equal to 0.0210, correct to 3 significant figures. So let's compare this value that we got from x is greater than or equal to 5 to our significance level. So 0.0210 is less than 0.025. So according to our rejection rule, we have to reject H naught. Alright. And now we have to conclude in context. So we can say there is sufficient evidence. There is sufficient evidence. At the 2.5% significance level, sig level, to suggest that the mean number of inquiries has increased, because they were testing for an increase in the mean number of inquiries. So according to our test, we got that we have to reject H naught. H naught was saying that lambda has remained the same. So if we're rejecting that lambda is still the same, it means lambda must have increased. So to suggest that the mean number of inquiries has increased. Okay, and this here would be our final answer. So notice how the steps for carrying out a binomial test and a Poisson test are pretty much exactly the same. The only difference is how you evaluate your probability with your test statistic. Here we're using Poisson probabilities. For binomial, of course, you use binomial probabilities. So that's how you carry out a hypothesis test under discrete conditions. Make sure to go through the quiz, and I'll see you in the next video.